Welcome to another video. The topic now will be bond pricing. And we'll start off with a method of bond pricing known as the yield to maturity approach. Now, the yield to maturity approach is not a very good way to do things, but it's a good way to start trying to understand. So, some terms that are important. We need to know coupon rate, maturity. We need to know face value. We need to know original issuance maturity. And we need to know yield to maturity. Okay, so these are some of our terminologies that we need to be aware of. So let's go. Corporations often issue bonds where they receive a bunch of money and then make interest payments often twice a year and then repay the money at the maturity date. Okay, and we're going to talk about the type of bonds. So the idea is if a corporation borrows money at, say, date zero, let's say it borrows $100 million at 10% per year interest, that means every 6 months, our period will be 6 months, so every 6 months it's got to pay 10% of the $100 million or $10 million. So its payments are $10 million at date one, $10 million at date two, and these dates are separated by 6 months. So date two would be 1 year, date three, 10 million. Let's say it's a 20-year bond, so out here at date 40, 10 million in interest, plus repay the 100 million. So these are the promised cash flow streams of this 40 period or 20-year bond. Okay, the 10 million amount here and here and here and here, as well as dates 4 through 39 also. These are the coupons. Coupons are measured in dollars, okay? Now, since we had a coupon rate that on a per period basis ended up being $10 million on a $100 million bond issuance, obviously then the coupon rate is 10%. Okay, so the coupon rate, 10%, is generally given. Okay, coupon rate is generally given, and the size of the coupon will just be the decimal version of the coupon rate, say the coupon rate divided by 100, multiplied by the principal amount. Okay, principal amount measured in dollars. So in our case, the coupon will be the coupon rate of 10% divided by 100, or 0.1, which is 10%, of course, times 100 million. And of course, that's 10 million. Okay. So again, here's the coupon. Here's the coupon rate. Okay. Now, the promised cash flow stream of the bond is what's shown in this area right here. That's the promised cash flow stream of the bond. Now, from the perspective of the corporation, these are cash outflows. From the perspective of the bondholders as a whole, these are the cash inflows. But let's look at a particular bondholder now, okay? So All bonds have face values or maturity values of $1,000. So from the perspective of one bond's cash flows, in that example, we have the following cash flow stream: 20-year bond or a 40-period bond. 10% of $1,000, okay, would be $100. So the promised cash flow stream for a holder of one of the bonds, max, would be as shown here, okay? These are the promised cash flows of the bond. Now, a yield to maturity, YTM, is an interest rate that is appropriate or is to be associated with a given bond. We'll see later it's generally reflective of maturities and default probabilities, and bonds can be lumped into categories, so we can often estimate yields that are appropriate for a particular bond if that bond is new to the horizon. Okay, so let's just say at the time this bond is issued, the yield to maturity is 10% per period. Well, what would be a fair price for this bond? Well, this yield to maturity, 10%, is going to be our discount rate, R. Okay, it's going to be a discount rate. So that means the price of the bond right now, say at date 0, will be equal to, we could look at the cash flows individually, 100 divided by 1 plus R to the first power, which would be 1.1, plus this second cash flow. Okay, here's the second cash flow now, plus that 100, since that occurs at date 2, in order to get the present value at date 0, we now have to go back 2 periods. So that would be 100 times 1 over 1.1 square, which is the same as 100 divided by 1.1 square. And then for this cash flow here, its individual present value would be 100 divided by 1.1 cubed, and then plus dot 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 plus. The last term would be 1100 divided by 1.1 to the 40th power. Okay, you add all those up, and lo and behold, the coupon rate here is obviously 10% because the coupon is $100, which is 10% of a $1,000 maturity value. So we see the coupon rate is 10%, and it's quite obvious that the discount rate is 10%, right? And whenever the coupon rate and the discount rate are the same, and we're valuing the bond 1 period prior to the first cash flow, I know you've looked at my series on time value of money, then you know that whenever we are using or calculating present values within the context of bonds, using the yield to maturity approach to bond pricing, we always get the value 1 period prior to the first cash flow. Just the way we set this up. And 1 period prior to the first cash flow would be date 0, right? Because at date 0, we make the investment, and at date 1, we get a coupon payment, at date 2, coupon payment, and the maturity date, we get the coupon payment plus 1,000. And what we see is that this is going to be equal to 1,000. The price will be equal to 1,000. Okay, because our terms, we got terms again were 100 divided by 1.1, 100 divided by 1.1 square, all the way out to 1,100 divided by 1.1 to the 40th power. Do the arithmetic on that, you will see that yes, indeed, this side of the equation is indeed equal to 1,000, of course. All right. So we see that whenever the yield maturity and the coupon rate are the same, bonds price will be 1,000. Now, when we price bonds, we're talking about a price at a coupon payment date. So either at date 0, or date 1, or date 2, or date 3, and so on. In the real world, bond prices will vary. If we look at, let's say, if we assume that the yield and maturity for the bond is the same as the coupon rate during the bond's life, then we can observe the following. Okay, there's date 1, date 2, date 3, and my point here is that if this horizontal line represents 1,000, okay, then the price of the bond, looking at points in time between now and date 1, which is one period from now, the bond price will look like this, at least as utilized for purposes of determining accrued interest payable. So there we have, at 1,000, and then it goes to this value. This value right there would be 1,100. And the idea is, for a brief moment just before date 1, your bond's worth $1,100, and then at date 1, the $100 is paid, so the bond value falls back to 1,000, and then rises again, and then falls, and then rises again, and then falls. This analysis here is based upon the assumption that the YTM is equal to the coupon rate. Okay, and again, we're in the type of analysis known as the yield to maturity approach to bond pricing. Okay, so if you were to buy a bond, let's say right here, okay, then what's going to happen is you're going to get the coupon payment of $100 at date 1, but you only have held the bond for half a period, from 1/2 to date 1. And you're going to get the entire coupon. So the idea is when you buy the bond, you would pay a price that would include the accrued interest. So if the yield to maturity and coupon rate were the same, and you bought the bond 1/2 way through the first period, say 3 months after you bought it, then you would pay, if you were buying the bond, you would pay $1,050. Okay? And of course, the person selling the bond would sell it for $1,050, because the new buyer at date 1 is going to receive the entire $100 interest payment, right? And since they only held the bond for 1/2 of the period, then they are only entitled to $50 in interest. So if you think about it, when they get the $100, that's $50 more than what they paid. So the difference between this and this, right, the difference is obviously $50. Okay? That's enough for this video. Thanks for watching.